Okay, so this lesson is on solving quadratics by factoring. And so last class we learned how to solve by graphing in Desmos. And this lesson is about how to solve without a calculator. And so we're going to do it all by hand. And so in order to solve quadratic equations, we're going to have to solve some linear equations. So that's what this warm-up is for. And so if we're solving for x, we need to isolate x. And so this minus 5, we have to get rid of it by adding 5, because that's the inverse operation of subtraction. And so those cancel, leaving us with x equals, and then 0 plus 5 is 5. And so our solution to this linear equation would be x equals 5. On number 2, we have two numbers hanging out with x. And so you have to get rid of the number that's furthest away first. And so that would be the 3. And so step 1 is to subtract the 3 from both sides. And then that would leave you with a 4x equals 24, and then divide by 4. And so when you divide both sides by 4, you end up with x equals 6. Okay, and so that's all we really need for this lesson. Number 3 is a little more complicated, but we won't end up seeing anything like that when we're solving quadratics. So we're going to skip that. We're going to skip the vocabulary and go straight to finding the zeros, which is the same as finding solutions. Zeros is another name for the solutions, which is also called x-intercepts, which we also call roots. And so the acronym for this was ROXS, R-O-X-S, for roots, all of the things I already just wrote. Roots, zeros, x-intercepts, solutions. Okay, and so the idea here is if you multiply two things together and it equals 0, one of those factors would have had to have been 0. 2 times 3 wouldn't get you a 0, but 2 times 0 gives you 0. And so that's called the zero product property, and that's what we use to solve quadratic equations. And so if this factor times this factor equals 0, one of these factors had to have been 0. And so what we do is we set each factor individually equal to 0, and then solve these linear equations just like we did the warm-up. And so in this case, I would subtract the 7 from both sides, and that would give me x equals negative 7. In this case, I would have to add, always doing the opposite, the inverse operation to cancel it out. And so I get x equals negative 7 and x equals 3. And so if you were to graph this in Desmos, you would have a parabola. You would be typing in the entire left side into Desmos, and that would give you this parabola that has x-intercepts at negative 7 and 3. X-intercepts are the same thing as the solutions. Okay, so for number 2, they don't have it in factored form. And so we need to factor it first. And so this is where our methods from Unit 6 come into play. And so I need two numbers that multiply to 45, but add to negative 14. So two numbers that multiply to 45, but add to negative 14 would be negative 5 and negative 9. And so my factors are x minus 5, x minus 9. Now be careful, these aren't your solutions. These are just your factors, okay? And so I want to take this time to label these as factors. This is not another word for solutions. Remember, ROXS, there's no F in ROXS. It's roots, zeros, solutions, x-intercept, not factors. The factors are in parentheses, and they don't have equal signs. To get the solutions, we have to set each factor equal to 0 and then solve for the x by doing the inverse operations. So in this case, we get x equals 5. In this case, we get x equals 9. And so these would be our solutions. Solutions have equal signs. Factors do not. They have parentheses. Okay, and so if you were to graph this in Desmos, you would have another parabola, and then you would see the x-intercepts at 5 and 9. And some of you are probably already noticing that your solutions have the opposite signs of your magic numbers that we found. And so that pattern is always going to hold true. If your magic numbers are 7 and -3, your solutions are -7 and +3. That's going to be a shortcut for us later. All right, so for number 3, we're missing the middle term. And so we could rewrite this as n squared plus 0n minus 16. And so this time I need two numbers that multiply to -16 but add to 0. Multiply to -16 but add to 0. And so those numbers are -4 and +4. That's a difference of squares, if you remember that from Unit 6. So my factors are n-4 and +4. And so we would set each of these individually equal to 0 to get our solutions. And so in one case, I would get n equals +4, and in the other case, I would get n equals -4. Okay, and so in Desmos, my parabola would have x-intercepts at -4 and +4. Okay, for this one, I need two numbers that multiply to 81, but add to -18. Those numbers are -9 and -9. And so my factors are w minus 9, w minus 9. This is called a perfect square trinomial because our factors match. They're the same factor. And so in this case, we're only going to get one solution because we only have one unique factor. And so this would be just w equals 9. If you were to graph this, this is one of those cases where the vertex lands on the x-axis, and in this case, it's at 9. Right, we're going to do 5, 7, and 9, and that will be enough. Okay, so for 5, it's a little bit harder because your a value isn't 1. In all of the cases above, the a value was 1, which makes it super easy to factor because once you have your magic numbers, you just write your factors. Okay, in each case, once we found our magic numbers, we had our factors. If your a value isn't 1, it doesn't work that way. But in this case, that 3 actually goes into each of the other terms. 3 divides 3, 24, and 21. So it's actually a GCF that we can go ahead and factor out. And so when I divide everything by 3, that leaves me with x squared minus 8x plus 7. And then our a value is 1. And so now I just need two numbers that multiply to 7, but add to -8. And so those numbers would be -1 and -7. And so x minus 1, x minus 7, and then technically that 3 should still be there. But when we're solving, it doesn't really make a difference because you're only going to have a solution where you have an x. If there's no x here, you can cross it off and ignore it. Okay, you only have a solution where you have an x. And so here's where our two solutions are going to come from. We're going to set the x minus 1 equal to 0, the x minus 7 equal to 0, and then solve for the x. We get x equals 1, and we get x equals 7. Okay, and so if we were to graph this, it would probably be a little bit more narrow of a parabola because of that vertical stretch by 3, but it would still have x-intercepts at 1 and 7. Okay, number 7 is a little bit different because in every other example, we were already set up to equal 0, equal 0, equal 0. Even if you're using Desmos, you need to make sure your quadratic is set equal to 0. And so if you have something on the right-hand side, like in this case, we have 15m, we need to go ahead and move that to the left-hand side by doing the inverse operation, which is subtraction. And so be careful not to combine this m squared with the m. Those are not like terms. You need to rewrite both of them and leave them separate. Okay, and so now we have our equal 0 on the right. And this is a quadratic that only has 2 terms. If that's the case, look for which term you're missing. In this case, we're missing the constant term. And so if that's ever the case, you have a GCF guaranteed that involves the variable. Okay, in this case, it's m. There's an m involved in both one because I don't have a constant term. And I can also get a number out of each of these. I can divide them both by 3. And so 3m would be a GCF here. And I can go ahead and divide this by that 3m. And it would leave me with 2m minus 5. Okay, and so now be very careful with this. This time our GCF does have a letter. Okay, and the GCF example above, that 3 did not have a letter, so we could cross it off. Do not cross it off here because where there's a letter, there's a solution. Okay, and so I need to set the 3m equal to 0, just like any other factor, and the 2m minus 5 equal to 0. And so to solve this, that's multiplication. I just need to divide by 3, and 0 divided by anything is still 0. So 0 is allowed to be a solution. 0 is a number just like any other number. And then in this case, we have to add 5 first and then divide by 2. And so this one ends up being a fraction. So if you have a fraction as your solution, leave it as this simplified fraction. Fractions are better than decimals, especially repeating decimals. And so if you were to graph this in Desmos, it would go through the origin because that's where 0 is. And then also go through 5 halves or 2.5. Desmos will give you the decimal first. Okay, number 9. This one's the most in-depth one. And so if you can handle number 9, you can handle anything on the test. And so this is another one that we need to set equal to 0. And so we need to get rid of this 2x squared and the 7x, but I'm going to take it one step at a time, starting with the x squared, because there's an x squared over here on the left side I can combine it with. So when I subtract 2x squared from both sides, that leaves me with a 2x squared on the left, and we still have a plus 3. And then we have our equal sign and our 7x. Now I still have to get rid of the 7x as well. And so when I subtract the 7x, there's no term to combine it with. And so I just have to write it with the others. And we're going to write it right in the middle because that's where the x term goes. We got to write them in order. And so that leaves me with 2x squared minus the 7x plus the 3. And now it equals 0. It's important to write it in order because we're factoring. We need our a value, our b value, and our c value. Okay, and so this one's harder than the others because our a value is 2. And that 2 doesn't divide the other numbers, so it's not a GCF situation we can factor out. So we have to factor this one the longer way. And so the longer way involves multiplying the a value times the c value. In this case, it gives you 6. 2 times 3 is 6. So I need two numbers that multiply to 6, but add to this -7. And so those numbers are -1 and -6. And so you can't just skip to x minus 1, x minus 6, because that wouldn't multiply back to give you a 2x squared. So that's why we have to do this the longer way. And so what we do with those, oops, need that to go away. That's wrong. What we do with the -1 and -6 is split the middle term. So -7x, we're going to write it as -1x minus 6x. And then just bring down the +3, bring down the 2x squared. And then draw a line right down the middle. Don't chop off any signs. And then we're going to look for GCFs out of each pair 2 at a time. So out of the first pair, 1 is the only number that divides 2 and 1, and then we can divide it by x as well. And so 1x is the GCF, and then I'm going to go ahead and get rid of that invisible 1 so that we don't complicate it. 2x squared divided by 1x would leave me with just a 2x. -1x divided by 1 is just -1. Over here, the leader is negative, so my GCF is automatically negative. And then we can also divide by 3. So we're going to write -3. -6 divided by -3 is 2. With the x, 3 divided by -3 is -1. Now, notice the 2x minus 1 and the 2x minus 1 match. That means we've done everything right in our factoring process. And so that 2x minus 1 is one of our factors. The other factor comes from what is in front of the parentheses. So in this case, it's the x minus 3. Okay, and so now we're finally ready to set each one equal to 0. So we set the 2x minus 1 equal to 0, the x minus 3 equal to 0, and then solve them individually. So add 1 to both sides first, then divide by 2, get a nice pretty fraction. And then over here we just need to add 3. Okay, and so I just want to reiterate that these are your solutions. And so if the question is asking for your solutions, you're looking for what x equals. Okay, if they ask for the factors, they're asking for these expressions in parentheses. And so no equal signs, they're just expressions in parentheses. And so this is the most in-depth problem we had. You first had to get it set equal to 0. Once you have it set equal to 0, you've got to get the factors, and we had to do it the long way. And then you can set your factors equal to 0 to get your solutions.